Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.2, Integration of Trigonometric Functions, part 1. Let's begin with useful trigonometric identities. First identity is sine square x plus cosine square x equal 1. Divide both sides by cosine square and we have tangent square x plus 1 equal secant square x. Now let's reduce the power of sine square x. We have 1 over 2, 1 minus cosine 2x. And if we reduce the power of cosine square x, we get 1 over 2, 1 plus cosine 2x. Sine 2x is 2 sine x cosine x, which gives us the identity cosine x sine x or sine x cosine x is half of sine 2x. We have a general identity for sine A cosine B. Sine A cosine B. In general, it will be half of sine A minus B plus sine A plus B. Sine A sine B is half of cosine A minus B minus cosine A plus B. Cosine A cosine B is half of cosine A minus B plus cosine A plus B. These are useful identities in the example that we're going to do next. Number 2, integrate the form sine x to the n multiplied to cosine x to the m dx. Let's take a look at an example. A, integral of sine to the 3x cosine to the 2x dx. Notice that we can only use the identity if the exponent of sine and cosine are even. So we can write sine to the 3x as sine square x times sine x times cosine square x dx. And now, well, notice that derivative of cosine is negative sine. So we got to use identity on sine square x. And that gets us 1 minus cosine square x times cosine square x times sine x dx. With this, it will let u equal to cosine x, and du is negative sine x dx. Sine x dx is negative du. Use the u sub, and we have 1 minus u square times u square times minus du. Distribute negative 1, and the u square, we have integral u to the 4 minus u square du. This gets us u to the 5 over 5 minus u 3 over 3 plus c. Do the back sub, and we have cosine x to the 5 over 5 minus cosine x to the 3 over 3 plus c. Nice. Let's take a look at another example in which the exponent sin x and cosine x, they are even. Integral cosine square x sin square x dx. Well, there's an identity for sin x cosine x, so let's use it. Sin x cosine x to the power 2 dx. Used identity, and we have integral half of sin 2x square dx. So this integral of 1/4 sin 2x square dx. Well, we're going to use another identity. The power reduce this one. So identity integral 1/4 times 1/2, 1 minus cosine 2 multiplied to the angle 2x dx. We have 1/8 integral 1 minus cosine of 4x dx. 1/8. The integral of 1 is x to integrate cosine 4x. We let u equal 4x, and so dx is 1/4 of du. The antiderivative of cosine is sine, so we get negative 1/4 sine 4x plus c, and this gets us 1/8 x minus 1/32 sine of 4x plus c. It's pretty cool. Now, what are we going to do with the general case of the integral of sine x to the n multiplied to cosine x to the m? There are two cases that are very general. First case is that if n is odd, then u is going to be cosine x, because the derivative is going to be sine negative sine x, and that is going to help us to reduce the power odd into the even power. And we also have to use the identity. Use sine square x is 1 minus cosine square x. The other case is if m is odd, then u is sine x, and we're going to use the identity cosine square x equal to 1 minus sine square x. Let's move on to 3. Integral of tangent x to the n multiplied to secant x to the m dx. First example, integral tangent to the sin x secant to the 4x dx. Notice that the derivative of tangent is secant square, so we can split out the secant to the 4x and rewrite secant square x in terms of tangent square x. That will be useful to solve this problem. Okay, so it's integral tangent to the sin x multiplied to secant square x times secant square x dx, and we use the trig identity. integral tangent to the sec x. Secant square x is 1 plus tangent square x. Secant square x dx. Now it is very clear on what u is supposed to be. U is tangent x, du is secant square x dx. We have integral u to the sec 1 plus u square du. So that is the integral u to the a plus u to the sec du. u9 over 9 plus u7 over 7 plus c. Do the back sub and we have tangent x to the 9 over 9 plus tangent x to the power 7 over 7 plus c. Very cool, huh? Let's take a look at another example. Here come B. In this case, the exponent is going to be odd instead of even. And take a look at integral tangent to the power 5x secant to the power 7x dx. Well, we can only use the identity if the exponent of tangent x and secant x are even, or one of them has to be even. Now, in order to use the identity, we can rewrite this as tangent to the 4x secant to the 6x times secant x tangent x dx. Well, derivative of secant x is secant x tangent x, so we need to rewrite everything in terms of secant x. Okay, use the identity on tangent. So identity the identity for tangent square is secant square minus 1, just integral secant square x minus 1 to the power 2 secant x to the 6 times secant x tangent x dx. Well, here u is secant x and du is secant x tangent x dx. So we have integral u square minus 1 to the power 2 u to the power 6 du integral u4 minus 2u square plus 1 times u to the 6 du integral u to the 10 minus 2 u to the 8 plus u to the 6 du, and the antiderivative is u11 over 11 minus 2 u to the 9 over 9 plus u to the 7 over 7 plus c. Do the back sub and we have secant x to the power 11 over 11 minus 2 secant x to the power 9 over 9 plus secant x to the power 7 over 7 plus c. Ta-da! This gonna get us to two general ways of integrate tangent x to the n times secant x to the m. The first case is the power of secant is even, so that is m is even, then we're gonna have to let u equal tangent x. And we use the identity secant square x is 1 plus tangent square x. That another case is the power of tangent is odd, so n is odd. In this case, we let u equal secant x. And we used the identity tangent square x equal secant square x minus 1. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.